Tommy, I found out the TV.
Crikey! I discovered theory!
Hello?
Mr. Chow, would you want to come over to my house for a tea party tomorrow?
Oh, that's a very good idea. Okay, I come so quickly.
Okay. Good morning, Mr. Chow.
How are you doing today, Mr. Wonton?
I'm very good today. Would you like some tea?
I like the tea. Can I have the oolong tea?
I'm sorry, we only have the Earl Grey tea right now.
Oh, that okay.
Okay, good. Here's your tea, Mr. Chow.
Oh, thank
Would you like some crackers?
you. Yeah, I want to have the cracker. Can I have the hot sauce with a cracker?
Oh, okay, sure. Hot sauce.
Thank you for the hot sauce.
Yesterday, I was solving some trigonometry equations, and I found out a possible proof for the Pythagorean theorem.
Oh, no, mate. I also do the same. When I do the Chinese checker, I found out the right angle was also part of the Pythagorean theorem.
Oh, that's awesome! Some of you may already know about the Pythagorean theorem, which allows us to find the sides of a right triangle. The theorem states that a squared plus b squared equals c squared, where a and b are the legs of the triangle, while c is the hypotenuse or the longest side of the triangle. But do you know the reasons and proofs behind the theorem? Studying these proofs will give us a better understanding to the theorem. This is proof number 72. This proof shows us why a squared plus b squared equals c squared. In the middle of the figure is a right-angled triangle. Let the shortest side be a, the longer side be b, and the longest side be c. The squares in each side of the triangle represent a squared, b squared, and c squared. Because the area of a square is derived from the equation side times side or side squared. We can see that the squares are divided into different pieces. If we rearrange the pieces of squares A and B to look identical to square C, then the figures are actually identical. This shows us that a squared plus b squared is c squared.
Oh, well played, so one point. But I think my theory is the better one.
This is proof number 24. Just like proof number 72, which was explained earlier, there are squares on each side of the triangle to show that a squared plus b squared equals c squared. 3 identical triangles will be added to the sides of the square a and b, and the side of the square c.
If placed in these positions, we can see that both figures are actually identical. Triangle 1 would be equal to this, triangle 2 and this, triangle 3 and this. In addition, this side of the figure is equal to this side of the figure, while this side of the figure is equal to this one. Also, this side would be equal to this.
Therefore, a squared plus b squared equals c squared.
Oh my, they both actually prove the Pythagorean theorem.
Good lord. Stupendous. Brilliant.
Oh.
But how do we apply this in real life?
I think I know the answer to that.
Sairon II is a grade 6 student in Xavier School. He's running late to school and arrived at 7:22, and school starts at 7:30. He has to find the fastest route to his classroom, grade 6I. He arrived at gate 4, so he has to pass by the quadrangle, a rectangle with dimensions of 12 meters by 35 meters. He cannot pass by the side of the quadrangle because classes are about to start. To get to the top of the floor, he must pass up the X ramp, which requires 2 ramps to get to the top of the floor. One ramp has a base of 12 meters and a height of 5 meters. His classroom, grade 6I, is at the end of the 30-meter hallway. If he runs at a rate of 10 meters per minute, will he get to the class in time?
The fastest way across the quadrangle without passing the sides is diagonally across it, or the hypotenuse. To find the hypotenuse, we must use the Pythagorean theorem, a squared plus b squared equals c squared. So 35 squared plus 12 squared equals 37 squared. Now the base of a ramp of the X ramp is 12 meters, while the height is 5 meters. To find the hypotenuse of the ramp itself, we have to use the equation a squared plus b squared equals c squared again. 12 squared plus 5 squared is 13 squared. Since there are 2 ramps, the total length of the X ramp he has to pass is 26 meters. We add all the measurements to find the total length he has to go through. 37 plus 26 plus 30 equals 93 centimeters. The equation we must use is distance over speed equals time. Since he runs at a speed of 10 meters per second, our equation is 93 over 10 equals to 9.3 minutes. He will not arrive in time because 9.3 minutes after 7:22 is actually already 7:31 and 18 seconds.
Thank you again, Mr. Chow. It's a pleasure to meet a level 4 mathematician.
Oh, Mr. No problem. I remember when I was a level 3 mathematician. It's amazing.
Okay, thank you again. I'll see you next time, Mr. Chow.
Okay, call me.
Okay, sure. Goodbye.